Hey everyone, and welcome to The Explainer. If you're someone who loves diving into how our world actually works, you're in the exact right place today. We're going to be taking a look at the construction of the Panama Canal. And listen, we're not just looking at this as a moment in history, we're looking at it as an absolute masterclass in mechanical engineering and human ambition. This was a project specifically designed to link the Atlantic and Pacific Oceans, and the sheer structural ingenuity it took to pull it off is just mind-blowing. Let's get right into it.
But before we can even get to the solution, we really have to wrap our heads around the massive scale of the problem. Seriously, how do you move a giant, incredibly heavy ocean vessel over a mountain? Because that was the core geographical blocker engineers were staring down in Panama. They weren't just digging a simple ditch in the dirt. They were facing an incredibly narrow, absolutely formidable strip of deadly terrain with some really drastic elevation changes. You obviously can't just sail a heavy steel ship up a hill, right? So how exactly did they do it?
All right, here's our roadmap. First, the global routing problem. Second, clearing the site. Third, the water elevator system. And finally, revolutionizing global trade.
Okay, starting with Section 1, the global routing problem, bypassing Cape Horn.
We need to understand the immense global pressure that made engineers look at an impassable, deadly jungle and say, yep, we have to build a giant machine straight through that. It really boils down to what's known as the Cape Horn problem. Before the canal existed, if you wanted to move goods from the Atlantic over to the Pacific, you couldn't just cut across the center of the Americas. No way. You had to take this treacherous, incredibly lengthy journey all the way down and around the very southern tip of South America, Cape Horn. Linking the oceans across Panama was essentially the ultimate optimization problem. They had to bypass that dangerous, agonizingly slow route by fundamentally changing the infrastructure of global trade itself.
And as you'd probably guess, this wasn't an overnight fix. It spanned decades. The French actually made the first attempt at this massive project back in the 1880s. But the final successful phase didn't even start until the United States took over the project in 1904. A full decade after that, in 1914, the canal officially opened. But getting from that 1880s starting line to the 1914 finish line meant solving some seemingly impossible problems.
Which brings us to Section 2, clearing the site and defeating disease.
Before any kind of sophisticated mechanical system could even be built, they had to deal with the deadly terrain itself. In the 1880s, the French approach was essentially to just brute force it, try to dig straight through the jungle. But they hit an insurmountable environmental bug, malaria and yellow fever. The tragic result there was the loss of over 20,000 workers' lives. By the time 1904 rolled around, the U.S. approach had to be fundamentally different. They realized that before you pour a single ounce of concrete or move a single pile of earth, fighting disease absolutely had to be step one.
The strategy completely shifted. As the new approach made clear, success required way more than just excavation. It required winning the war against disease. Dr. William Gorgas was the pivotal figure here. He essentially patched this massive environmental blocker by implementing sweeping sanitation programs across the zone. By systematically eradicating the local mosquitoes that were responsible for spreading yellow fever and malaria, the site was, finally, prepared for the heavy machinery.
Moving on to Section 3, the water elevator system, otherwise known as the lock system.
Now that the site was actually viable, we get to look at the core mechanism itself. Consider this a quick technical tutorial on the mechanics. Digging a ditch straight through the mountains, all the way down to sea level, was nearly impossible. So engineers devised this massive lock system. Think of these locks as enormous mechanical chambers that act exactly like water elevators. Using basic hydrostatic mechanics, they rely purely on the natural flow and pressure of water to physically lift ships up and then over the terrain. It's just a stunning triumph of engineering over nature.
Let's walk step by step through exactly how this water elevator functions. Step 1. A ship sails right from the ocean into the very first mechanical chamber, and these massive steel doors close securely behind it. Step 2. Valves open up, and water from higher elevations floods right into the chamber. This acts just like an elevator car rising. It gently lifts the heavy ship up 85 feet into Gatun Lake, which is a man-made body of water they created specifically for this exact purpose. Then, Step 3. After the ship crosses the lake, it enters another chamber on the far side. The water is drained out, lowering the elevator car, and the ship along with it, right back down to sea level.
I really want to emphasize this number for a second. 85. We are literally talking about lifting massive, heavily loaded steel ocean vessels 85 feet into the air using nothing but valves and gravity. By utilizing water as a functional elevator,
engineers totally circumvented the need to excavate billions of tons of solid mountain rock. They used the environment's own resources, water and gravity, to seamlessly solve their biggest geographical blocker. It's brilliant.
Finally, Section 4, revolutionizing global trade and connecting the world. Once these locks were finally operational, the output was just staggering. To get this massive machine up and running by 1914, millions of cubic yards of earth had to be excavated. Engineers built one of the absolute largest earth-filled dams of its time just to create Gatun Lake. And medically, they achieved the marvel of eradicating local disease-carrying mosquitoes. When you put it all together, it stands as one of the greatest engineering feats in human history.
However, looking at the historical data, it's crucial we acknowledge the incredibly heavy human cost required to achieve this progress. Over 20,000 workers died during the initial French phase, and thousands more lost their lives during the American-led phase. It stands as a stark, sobering reminder of the immense sacrifice made by the workers who faced these extremely formidable geographical barriers to construct this machine.
The permanent impact of their sacrifice and that engineering brilliance is exactly why this matters to us today. When the canal opened, it fundamentally transformed the world into a much more connected place. Global shipping routes were permanently shortened by thousands of miles. Ships simply didn't have to brave the deadly Cape Horn anymore. It instantly revolutionized international commerce, meaning the goods you rely on every day could move faster and cheaper than ever before, and it entirely shifted global naval strategy forever.
Which brings us to one final thought to leave you with. If early 20th century engineers could build massive water elevators to literally lift ocean vessels 85 feet over a mountain range, what formidable geographical barriers will humanity conquer next? By breaking an impossible problem down into its parts, fighting the disease, engineering the water elevators, building the massive dams, they quite literally changed the map of the world. Thanks so much for joining me on this explainer. Keep asking questions, and I'll see you next time.